Now I'm going to talk about disjunctions. Okay, so let P and Q be propositions. Then P or Q is denoted P with a V and then a Q. And this is the disjunction of two propositions with the symbol that means or. Now, the disjunction P or Q is false whenever both P and Q are false, but true otherwise. In other words, only one or more of the two propositions needs to be true for the whole statement, the disjunction, to be true. So let's look at the truth table. If we have the disjunction truth table of P or Q, then I'm going to have 4 rows, because remember, using the multiplication principle with counting, you have 2 propositions, and each proposition can either be true or false. So I have 2 possibilities for proposition P, or 2 possibilities for proposition Q, and when I multiply them together, I get 4 combinations, 4 possible combinations. So I'm going to make sure that I have 4 rows. So I could have P is true and Q is true, or I could have P is true, Q is false, or I could have it the other way around where P is false, Q is true, or they could both be false. So those are all my possible combinations of true and false with P and Q. Now, the truth table for P or Q, remember in the definition I said that in order for P or Q to be false, both P and Q need to be false. All you need is one of those propositions to be true, or at least one to be true, and then P or Q is also true. So if we look, I have both of these are true. So P or Q is true. I have, in this case, P is true, Q is false, but one of them, at least one of them, is true. So P or Q is true. Then I have P is false, Q is true, but at least one of them is true, so P or Q is true. Now, here's the case where both of them is false, then P or Q is false. So here is our truth table for the disjunction of P or Q. This is an example, P or Q. This is the example of what's called the inclusive or. There is also an example of an exclusive or, which we'll get to here in a little bit. The use of the connective or in a disjunction corresponds of one of 2 ways the word or is used in English. The or that we just discussed in this truth table is called the inclusive or. That means that the disjunction is true when at least one of the 2 propositions is true. Later on, when we talk about the exclusive or, that means exactly one of those propositions are true. Right now, what I want you to know with the inclusive or, I'm going to say at least one proposition is true for the disjunction to be true. So let's go through an example of an inclusive or. We have the statement in English, students who have taken calculus or introductory computer science can take this class. I want to translate this into using our logic symbols with conjunction. Okay, so I'm going to let the statement students who have taken calculus be the proposition P, and I'm going to let students that took introductory computer science to be the proposition Q. So then I'm going to write this using logic notation P or Q. So when we talk about the inclusive or, remember the inclusive or is at least one of those propositions needs to be true in order for the disjunction to be true. And so at least means one or both could be true. So a student could have taken calculus, or a student could have taken an introductory computer science course, or the other possibility is they could have taken both, but either way they're still going to be able to take this class. So it's one or the other or both.